Have you ever looked at the sleek surface of your phone, or maybe the wild color on a modern building? Well, that finish, that incredible feel, it's not just a fancy coat of paint. It's actually an art form, a kind of science happening at a scale so small you can't even see it.
You know what I'm talking about, right? That premium feel, the way light just seems to dance across a surface, giving it this deep, almost magical quality. It isn't some new kind of paint or a special polish. No, the real story is so much cooler.
That's right. The surfaces we're talking about are literally built, constructed one atom at a time to create these very specific textures, colors, and properties. It's less like painting a wall and, I don't know, more like building it with microscopic Legos. So how on earth is that even possible? Well, let's dive in.
All right, so here's our game plan for this explainer. We're going to start with the basic idea of painting with atoms. Then, we'll check out the 4 main controls scientists get to play with. We'll explore how they can sculpt with atomic shadows, cook up new colors just by adding gas, and finally, we'll see where this amazing tech is already showing up in our daily lives.
Okay, let's get right to the heart of it. How in the world do you paint with something as tiny as an atom? Well, the answer is a process with a really fantastic name: sputtering. I want you to picture a can of spray paint. But instead of shooting out tiny droplets of paint, it's firing a perfectly controlled stream of individual atoms. That's sputtering in a nutshell. It all happens inside a vacuum chamber, which is super important to keep everything pure. And scientists basically bombard a source material, like a block of titanium, knocking atoms loose. These atoms then fly across the chamber and stick to whatever you want to coat, building up a film that can be hundreds of times thinner than a single human hair. It's wild.
But, just spraying atoms around isn't quite enough. To get those beautiful and really functional surfaces, scientists need precise control. The best way to think about it is like they're sitting at an atomic control panel with 4 main levers that can change absolutely everything about the final product.
So let's take a quick look at this control panel. These 4 levers are the key to the whole thing. First up, you've got angle. Now, this isn't just about where you're pointing the spray, it's about sculpting the very foundation of the surface to control texture and gloss. Next is pressure inside that chamber. Lower pressure lets the atoms pack in really tight for a super smooth finish, while a higher pressure gives you a more porous, matte look. Then there's power. This is basically how hard you're blasting the atoms off the source. More power gives them more energy, which usually means you get a smoother, tougher coating. And finally, my favorite, the most transformative lever of all, gas. By adding reactive gases like oxygen or nitrogen, you can fundamentally change the chemistry of what you're making, creating entirely new materials and a whole spectrum of amazing colors. All right, let's zoom in on that first lever, angle, and see how it helps build a completely new kind of surface. This technique is called Oblique Angle Deposition, and honestly, it's just a masterclass in using geometry at the nanoscale. So instead of firing atoms straight on, scientists shoot them from a really steep angle. And what happens is, the first few atoms that land form these tiny little peaks. And just like a real hill casts a shadow from the sun, these atomic peaks cast shadows that actually block other incoming atoms from landing behind them. It's this beautiful, self-organizing process. And this shows you exactly what happens. Step 1, you fire the atoms at a steep angle, somewhere around 60 to 65 degrees. Step 2, this creates those tiny initial peaks. Step 3, those peaks cast their atomic shadows. So what happens in step 4? The next wave of atoms can only land on top of the existing peaks, causing the whole structure to grow into these amazing tilted columns. This nanostructure is what gives a surface that unique textured appearance that can trap and scatter light in very specific, very cool ways. Okay, so sculpting the surface is one thing, but what about color? What about the actual material properties? For that, we turn to our 4th lever, gas. This is where we stop being sculptors and start being, well, atomic chefs.
Let's stick with our titanium example. If you sputter it in a pure vacuum, you get a thin film of, you guessed it, titanium. But if you introduce just a little bit of oxygen gas into the chamber, something incredible happens. The titanium atoms actually react with the oxygen atoms as they land, and you're no longer creating a titanium film. You're cooking up a brand new ceramic material, titanium dioxide.
And what's really crucial here is that even the amount of oxygen completely changes the outcome. With just a moderate flow, you get a crystal structure called anatase, and that gives you this beautiful, pearly, kind of translucent, matte finish. But if you crank up the oxygen, the atoms arrange themselves into a totally different structure called rutile.
This one's denser, way more reflective, and gives you a bright, glossy surface. Two completely different looks from the exact same starting material, all just by tuning the gas. It's incredible.
Now, this isn't just some cool lab experiment. This ability to design surfaces atom by atom has totally transformed the products we use every single day.
Seriously, the applications are everywhere. In architecture, those self-cleaning windows, they often use a sputtered coating of titanium dioxide. It's used to make solar cells more efficient, and it creates those tough, scratch-resistant, and beautifully colored coatings on our electronics. It's even used for things like biocompatible medical implants, durable parts in cars, and you know those distinctive golden drill bits? That's a hardened coating called titanium nitride, made by sputtering with nitrogen gas instead of oxygen.
So the next time you pick up a gadget or admire a building with a really cool finish, just remember, it's probably not paint. It's a marvel of engineering, a surface that's been sculpted and cooked atom by atom to be exactly what it is. It really makes you wonder, right? With this kind of atomic control panel at our fingertips, what are we going to design next?